It'll already be warm. Always make sure that it takes on both sides right there. Just like our thin piece right there, just push that rod all the way in the puddle. Don't be in such a hurry. All right, now there's our front side that we just welded right there. So we're going to flick it to the back side right there, and you can see the penetration. Just about 100%, but a lot of times where you want to flush it down, just come right back and keep that cone right there just up off the metal. You can actually see it wrinkling. Your rod won't take until it actually starts to wrinkle. Then just push the rod right in the puddle. Just like you're TIGging right there. Excellent quality weld on your horseshoes, especially the aluminum shoe. So you can actually see the front side and the back side. Now if you want to see how it cleans up, this right here is one that we just did in Louisville at the symposium for the farriers. The weld on the front side right there, and you can see just how nice, as they hasp it down and use their grinder, it cleans up very nice. Now also a lot of you guys that are still putting these shoes on, now we didn't know a whole lot about borium until we actually got back from Louisville. And actually putting the gun in your hands, we found out, compared to a regular torch, as you went to put this borium on, especially in between where you put the nails, it wants to spread. Well, what a lot of farriers really liked about our gun compared to a regular torch, if you're putting that borium on, whether it's on the edges right there, you got such a soft, concentrated flame that it goes exactly where you put the heat. And also, if you want to build those little tips up right there, you can actually see just how high that you can build those tips, because all that heat stays in just one small area. The heat don't flow. You go in there and weld it just like you would a regular torch, just get it hot. You can build it up. But you can actually see right there where you can build it up in between those shoes right there. So taking whatever size borium on whatever size shoe right there, you're going to love the results because of the concentrated and the very soft flame where you can actually put that borium wherever you want to go. Even on some of the aluminum shoes where they had that little borium cleat back in the back there, we were still able to come in and build that up even on the aluminum shoes. Now also, I'm going to weld a little radiator for you right here, and I think that we'll be through with aluminum. I've just taken a little heater coil and punched just a small hole in it right there. So we'll go right back to our 3/32 diameter on the aluminum rod. Now a lot of times you might want to use a 1/16 diameter rod on those real thin heater coils or radiators. Just get just a little bit more flux. All right, remember now we're going back down less than a 1/16. So we'll come right in here, take our number 2 tip off, and put the smallest tip right back on again. All right, we'll come right back and get that neutral flame. See if we can get our lens set up right here. We're doing all we can to actually show you as close as we can to how to weld with our gun. All right, now when you weld these little heater coils or your real thin aluminum, sometimes you can't push that rod in because it melts so quickly. So what we got to do is take that heat down and just sort of circle and keep dabbing with the rod. As soon as that rod takes, leave the rod in and just flow it around with the little cone right there, because you're dealing with some very thin aluminum, very dirty, you can see right here. And as soon as it starts to weld, just keep the rod pushed right into the puddle and then just flow it right around. Now you can see right there just how fine and just how nice, even on that real dirty, it's the only gun that you can actually weld dirty aluminum with. All right, now that we've finished with our aluminum, we're going to start welding some stainless steel. Now we're ready to weld some stainless steel. This right here is just some regular 304 stainless. We can weld from very thin stainless up to about a 1/4 inch on stainless. It's such a hard alloy. Now also, when you're welding stainless right here, if you've got 2 pieces butted together, you're going to get a little distortion. So we highly recommend about a 1/16 up to a 1/8 gap when you're welding your stainless. I've got just a couple 304 stainless steel pieces right here. So we give ourselves just a little bit of a gap. Now also, I'm using just a 3/16 stainless steel TIG rod. You don't have to use any flux or anything, just a standard TIG. Now a lot of you aircraft guys, we give you some different numbers on some of your aluminum, some of your stainless, and your mild steel. All that is in the instructional book. Now also with stainless steel, this is the only metal that we actually have to use a different type flame. We use a neutral flame on everything but stainless. Now just to show you what we're doing, you can actually adjust it with either one of your oxyacetylene knobs right here. But we need just a little bit more acetylene. Now, anytime you have a little feather sticking out like that, that's always what they call a carburizing flame, a little bit more acetylene. The longer that cone is, the longer it is, actually the cooler it is. All right, so we run it out there about twice the length as that little inner cone right there, and that's not critical, that's approximate. But you can see that little cone on the inside, so we still weld with the little inner cone. And the reason we do that, if you get any oxygen at all in that stainless, you crystallize it, make it very brittle and weak. So that's like a little added shield. So not the outer feather, but that little small inner cone right there. Also, I'm going to show you just a little easier way to weld with it. All I'm doing right here is actually just holding that rod right in the puddle, taking that little small cone, walking right up the rod, washing it right back in the puddle. Now I actually keep that rod pushed right into the puddle right there, taking that little small cone, walking up the rod in small, slow increments. People, for some reason, want to try and weld too fast with it, and all you'll do is just give yourself a lot of high and low peaks. Actually, watch that puddle spreading out. Just take that little cone, walk up the rod, wash it back into the puddle, and make sure it's melting. If you're welding stainless to stainless or stainless to any other metal, we tell you in the book just to use that carburizing flame right there. Now stainless will clean up very nice. You always have a little discoloration to it, no matter what you weld it with. Now if you look real close right there, you can also see we give you 100% penetration. For a lot of you guys out there that want a real nice cosmetic appearance, your stainless will clean up and buff up very nice. A lot of guys like the Jeweler's Rouge and the buffing wheel, but there's a lot of different compounds out there that you can clean it up with. In fact, all of our welds, the aluminum, stainless, and the mild steel, the Jeweler's Rouge and the buffing wheel, you can buff it out just like chrome right there. So if you're going to do your stainless, there again, just a carburizing flame and just a standard TIG or Heliart rod. So now we're getting ready to go and weld some of our mild steel. Okay, when you weld your mild steel, and we've got here about some 20 gauge right here, all right, still on our alt tip because we're less than a 16th. We do a lot of car shows, so a lot of people always asking us how come we get very little distortion. Now even on steel right here, if you butt it together, steel's going to go somewhere, you're going to get some distortion. So there again, even like stainless steel, we recommend a 16th to 1/8 gap. Even if you get some big gap welds, a 1/4 inch, because of that soft flame, you can still weld those up. Now, these right here are just small coupons. Even if it's dirty, rusty, oily, or greasy, if you're doing field welding, still does a very nice job. I've got a piece here that's just a little rusty, and one that's clean right here. Now, for a lot of you guys that are putting cars, putting fenders together and so forth, give yourself about a 16th to a 1/8 gap and tack it about every inch, inch and a half. Now, sometimes when you tack it, one might raise up, one might raise down. On a very long weld like that, just go back and hammer it down, and then just come back. You can start on one end and weld it up. Now remember, the great thing about oxyacetylene, especially if you're worried about distortion, is if you get any distortion because it is an oxyacetylene weld, you can actually hammer weld it out. It's a soft weld. For a lot of guys that are using the TIG or the MIG, it's what they call thermal shock in the metal. As you go in there and get distortion, you cannot come back and move that metal. It's a very rigid weld. That's when you got to come in there with your Bondo. So if you want very little distortion on your very thin sheet metal right there, just come in there, give yourself a 16th to 1/8 gap, and it'll do a very nice job for you. All right, so we're going to weld these two small coupons together for you, giving ourselves a 16th to 1/8 gap using just a regular copper-coated mild steel rod, a steel rod. If you got your MIG wire, just take that. We just did a farm show, fence wire. They use hay baling wire, coat hangers, the old standard reliable standby. But just a standard mild steel copper coating right there helps it flow a little bit better. It don't seem to stick as much. All right, still using the neutral flame right there. There again, just keep that little cone just up off the metal, and basically all I'm going to do is just like my stainless steel, I'm going to take that little cone, walk up the rod, wash it right back into the puddle, moving it very little. So just take that rod and that cone down at the same time. Now, on my mild steel, I lay the gun over maybe close to a 45 degree right there, a little bit more than the aluminum, keeping that rod pushed right in the puddle. And see, because that flame is so soft and so concentrated, all your heat's confined in a very small area. And also because of the low pressure coming out of that tip, you have very little blow through. Now if you do blow a hole, all you got to do is just push that rod right in the puddle and it'll fill it right in. Even on your longer wells, don't make a difference. You're still going to get very little distortion. Even on the end right there, if it sort of fantails on you, sometimes you might have to pull off of it for a second, go right back on it, and you can build it up till you got a very square weld right on the end of it. Now on that real thin sheet metal right here, you can see just how nice a bead you get. It's a very flat weld, so you have very little to grind off. Notice also just how little distortion you get even on a small piece, while at the same time giving you 100% penetration in case you want to come back and grind that off right there. It does an excellent job on that thin sheet metal. And not only your thin sheet metal, we can actually weld up to 3/8, and actually once you start getting over about 1/4 of an inch, you really start slowing down. The sticker MIG is going to weld your heavier pieces still much faster, but you can still take a small piece and weld it up, just 3/32 mild steel rod or 1/8. You can actually even take your stick electrodes, knock the flux off, and weld a lot of your heavier plate. Now when you start welding your heavier plate, it welds just like a regular torch. You must come in there and bevel your edges. Anything over 1/8 of an inch, you want to come in there and bevel it out. You got to get both sides to where it's red, and then go in and weld it up. And also, when I'm welding my heavier plate, I'll use a little bit more of a circular motion. Instead of just barely moving the torch on my heavier plate, I'll just circle a little bit more, making sure that that rod melts down in there. And sometimes you actually might have to make several passes on it. Now for a lot of you aircraft buff, I've done went ahead and welded one side right there. We're actually going to weld just a small piece of chromoly tubing for you. Now because our flame is actually so concentrated, now I'm going to set that lens down right here. I think you'll actually still be able to see right here if we set it like this right here for you. And let me see if we can get this right here. Maybe we can get it right here where you can actually still see it. Okay. Now, when you're welding your chromoly tubing, especially with a regular torch, they give you all different type rods. There again, I'm just going to use a regular mild steel rod with our torch. That is okay. Still using a neutral flame. This tubing is less than 1/16, so we're still using the alt tip. Remember what size, or actually what thickness of tubing you're going to weld. Remember, make sure that you get the right size. Now, just like a regular torch, we still have to come in there and just sort of preheat it, just sort of stress relieve it right there. You still want to come in and heat your tubing up. It's going to weld a whole lot easier. Now, one thing you'll find out about, because that flame right there is so concentrated, whatever angle you're going in, you always want it to heat on both sides. If it looks like all that heat is on one side, just adjust your torch a little bit to where that heat looks like it's heating both sides of your tubing right there while you're welding. And it don't make a difference what angle you're at. If you're coming back putting 2 or 3 pieces together, it's going to do an excellent job. And also for a lot of the guys out there that are a little bit older, a lot of times we have trouble with our hands shaking a little bit. Remember, with this gun right here, you can actually lay the rod right in the puddle and just take it and work it right in. Now, on my chromoly tubing also, I will take the rod and the heat down at the same time. Your metal, well, you can actually see it turning red. And a lot of times I'll still use just a little bit of a circular motion. I'll just sort of wash a little bit of that rod off, because I want to make sure that I'm getting a good penetration. I know a lot of the air shows that we do, people say that sure is a tiny bead right there. They're just so used to seeing a big, thick weld on that chromoly tubing. But just a big weld don't mean that it's better. You're still getting an excellent quality weld. Always try and keep that little cone right there out of your puddle. Now you're going to have to learn to work that torch just a little bit more, working around a lot of your tubing like that. Just make it a little more flexible right there with your wrist, so just get you some pieces and practice with it. because you're going to be doing a lot of out of position welding, which this gun still does a very nice job. The main thing on that tubing is always keeping that gun pointed to where you can see it heating evenly on both sides of your tubing. Now when you get through, especially if you're doing a cluster joint, you want to come back and post heat it to stress relieve it when you're putting a lot of weld into a lot of different joints. Now also if you're doing a regette weld where you got tubing sliding inside of tubing right there, you'll find that our gun does a much nicer job because you're not burning that tip off. Because of that concentrated flame right there, you still got total control on the outer side of that lip as you're welding the inside of it. So right there is your chromoly tubing. So now we're ready to go and weld some cast iron. When you're welding cast iron with our gun, we found out that if you will use a high heat or a welding cast iron flux instead of a brazing flux, that the results seem to be a whole lot better. We like our number 2 Peterson here, this number 2 high heat flux, but there again we give you the name and number of some other fluxes, which is all in our instructional book. Also, we just use just a standard 100% pure cast iron rod right there, 3/16, 1/4 inch diameter, 18 inches long. That's what we call a cast weld 111. So we give you the name and number in the book, but if you want to ask for it at your welding supply house, if they don't have it, Thermocoat Welco that makes your standard Tigger Heliart rods actually bought the company out that makes that cast weld 111. Now you can still use your nickel rod or your flux coated bronze rods, but a lot of times with your nickel you get such a high Rockwell hardness, it's very hard to drill, tap, and machine. You just about have to have a special carbide cutter. When we get through welding our cast, the machinability is excellent. Also, you don't have no discoloration as you go in and weld right there. If you can blend it and grind it down, you're just putting cast right back into cast. Now, we've been able to have some real good results even on a lot of the older casts. This is just an old manifold right here off of an antique car. It's real low. The more carbon, the harder it is to weld. But with our gun, we've had some real good results going to a lot of antique tractor shows and also a lot of your hit and miss engine shows. Been able to weld up a lot of that old difficult cast that your regular conventional torches and electric welders have been having trouble welding. Now we can weld from very thin cast all the way up to 1-inch plate. Now if you've got an oven, if you've got a barbecue grill, some sort of stove, all you want to do is come in and just sort of preheat it just a little bit. Now if you don't have an oven, you can take the torch. The preheating is not real critical with ours. Notice that we've come in here and just ground out some slots. You always want to grind out the crack that you're going to weld. And actually you want to go in there and just sort of preheat it just a little bit. We're going to heat our rod up, stick it in our Peterson flux. We're going to weld it up. The most important part on cast is coming back and post-heating it. Either stick it back in the oven, use your barbecue grill, stove, or whatever. If you don't have that, you'd have to come back with a torch and heat it up real good, heat that whole part up, because actually allowing it to cool too fast causes most of the problems with your cast cracking. Now, if you're doing a real thick piece, if you don't have an oven or a grill, you're going to have to use a regular torch to go in there and heat it up and post-heat it, because our gun is so concentrated that it would take longer to heat it. So if you're going to do a real thick or a real big piece, use a regular torch or a rosebud to preheat it and post-heat it if you don't have an oven. All right, so we're still going to use our neutral flame. That's about 3/16 to 1/4 inch, so I've got my number 2 tip, just a regular cast iron rod. All right, now we don't have an oven or a grill, so I'm just going to come in here. Let me move my lens just for a second. You will come in here and cut your flame up. You'll just come in and preheat it just a little bit. We're just going to knock the chill out of it, just enough of where you can touch it, and it's still just a little bit warm. We'll come back and weld this one right here. Now you will also need just a regular standard Shade 5 oxyacetylene lens for all of your welding, except on the aluminum. Something I forgot to mention when we was welding aluminum, that if you're going to do a lot of aluminum, we have a didymium glass. They make some cobalt lenses, but you will definitely need a special lens if you're going to do some aluminum welding and do a lot of it. Sometimes with your standard Shade 5 glass, it's real hard to see that glare because of the flux, so you might have trouble seeing the weld puddle. All right, so once you preheat it, just come in here and just heat your cast iron rod up just a little bit. All we're going to do is just stick it in the flux. All right, we're going to come back, stick our lens up right there, so a neutral flame. All right, and we're also going to come back and cut the heat down. You're going to find out that you don't need much heat to weld that cast. If you're too hot, you're going to blow through. If you're not hot enough, it's just not going to melt. Now just lay that rod right down into that groove. And so what we're going to do is actually put all the heat right on the rod. It'll take just a second to wash that rod right down in the groove right there. Now every time that we actually wash that rod into that groove, you're going to see us move our torch back and forth right across that weld that we're going to weld up, that little groove right there. And it'll let you know when the temperature's just right, that cast will start flowing just like butter in a pan. Then just come right back, get a little bit more rod, just be patient with your cast, run the torch back and forth, come back, lay your rod right back in there, wash the rod off, and move the torch back and forth. Now the amount of penetration you want down in that groove depends on the amount of heat that you hold right there. The more heat you hold over that groove, the more it's going to penetrate. But it seems to weld cast about as good as it does anything. That very low pressure, you're not blowing the puddle out. Very soft flame. Now a lot of people want to know if we can build it up. Just let the redness go out right there. So if you want to come back and make another pass, as long as you're getting a good smooth flow right there, you don't need any more flux. Now every now and then we'll run across a real dirty piece. And every time you try and weld it, it looks like it don't want to flow real smooth. Go ahead and make that initial pass, trying to get it to flow as good as you can. It's just floating those impurities to the top. And usually by the time you go back over it, you can get it by that second or third pass on that extremely dirty stuff. As you can see right there, you can make pass after pass after pass and build it up. All right, so at this point right here, if you don't have an oven or a grill to put it back into, we're going to take our torch, cut the heat up. We're going to go back and post heat it.